and welcome to ChefComp 2021 online, where I am joined by Kiah Tolliver today. We are planning the perfect app deployment with Habitat. I'm super excited by this one, and we've got some questions at the end we'd love to answer. If you've got any questions, please drop them in the chat and we will answer them at the end. If you're not in the chat and you're watching later on live stream, just pop into the DevRel room and we'll happily chat there as well. Brilliant. Kiah, take it away. Thank you very much.
Awesome. Thank you, Dan, for that marvelous introduction. Let me share my screen. Hi, everybody. I'm Kiah Tolliver. Thank you for coming to my talk. So today we're actually going to be talking about planning the perfect app deployment with Chef Habitat. Just a brief introduction about myself. I'm a DevRel or developer advocate here at Chef, and I moonlight as a startup founder, and my startup is called C-Tracks. You can find me on my blog, blackgirlcto.com, and also on Twitter at blackgirlcto. Okay, so what are we going to be talking about today? Like I said, we're going to be going over planning the perfect app deployment with Habitat. But first, we're going to need to go into some app delivery fundamentals. Then we're going to figure out what the heck Chef Habitat really is. Then we're going to dig deeper into the application definition, which is the plan. Kind of like the nucleus that everything that Habitat centers around. Then we'll do a brief high-level Habitat architecture overview. And finally, we'll wrap up and open it up for questions. Sound good? Let's go. I'm sure I don't have to tell everybody this, but modern application delivery is hard. Organizations today have every form of application within them, from microservices to mainframes. Applications are highly interconnected and floating in a sea of dependencies. Changes in one area can cause failures in another, and we've all experienced this. The responsibility for these components fall to different teams that are siloed from one another, adding even more friction and to velocity, and also increasing tech debt, which we want to keep to a minimum if possible. Can never get rid of it, but we want to keep it to a minimum. Systems are also undergoing constant change. In addition to the changes to the application, there's going to be operating system changes, updates to the infrastructure and those supporting changes, and also security policy updates, network configuration changes, and tons of other events that can impact an application. And the challenges just continue to increase. Every new technology brought into an organization's tech stack adds to the list of things that must be updated, secured, and maintained. As an application developer or a DevOps guru, you want to spend more time making the application awesome and less time configuring environments, remediating deployment issues, and troubleshooting build scripts, and also patching outdated software. And that's what Habitat does. Habitat improves the way IT teams work together to build and release applications. So what does that look like? How do we solve the problems that we've been discussing? Well, start off by defining your application delivery requirements. You'll put that definition into a usable format, which is a coded artifact, so that we can then take that artifact in version control, where it can be consumable by your CI/CD system of choice. You can then automate your upgrades in your dev, staging, and production environments. And you most likely integrate with other tools like repositories, provisioning solutions, and secrets management. So you'll need a tool that supports those integrations as well. And you'll also want to be able to deploy across multiple environments and clouds without having to go back to your dev team. And you want to be able to also see the status of those deployments across those different clouds and environments in a single place. So what is application definition? Application definition is the process of creating a codified operational runbook. Chef App Delivery explicitly models and defines and isolates these dependencies as code and stores them in a common code base along with the application binaries. By identifying and defining everything an application needs to be built, run, and maintained as a part of the development phase, failure identification is shifted left from runtime to build time. That just makes everybody's life easier. Let's get into a plan. So artifacts are the cryptographically signed tarballs that are uploaded, downloaded, and unpacked and installed in Chef Habitat. They're built from these shell scripts known as plans, but they include application lifecycle hooks and service configuration files that describe the behavior and configuration of a running service. As a way to start understanding plans, let's look at this example. We're looking at a plan.sh file. Now, what we're looking at here is a plan file for a Java Tomcat application. Historically, in order to get this deployed, I need to be a Java developer. I need to build like a WAR file or a jar file in Eclipse. And I need someone to go and install Tomcat on some infrastructure for me and build my artifact to deploy in a Tomcat. Well, with Habitat, Tomcat is just a dependency. Plan file is a directory comprised of shell scripts and optional configuration files that define how you download, configure, make, install, and manage the life cycle of the software and artifact. So we're going to go down and kind of talk about the plan file and what makes up a plan file. So first we have our metadata. Plan file defines important metadata about an application, like its name, origin, and version. And these are generally like, these things are the same for every application. We're gonna always have this metadata piece. Next, Chef Habitat explicitly declares and isolates dependencies as a modular set of plans that are used to model an app as a coded artifact. So within these plan files, users can declare two types of dependencies, build time and runtime. Build time dependencies will be available within the Chef Habitat Studio and are needed to package the application. And they're declared using this package build deps declaration. Runtime dependencies, on the other hand, are shipped with the binary. These are also needed to run the application. These are declared using the package deps declaration. There's also another type of dependency called transitive dependencies. These don't need to be defined, but they're installed as a part of the defined build and or run dependencies and don't need to be explicitly declared. Let's move down to binds. Here, package binds is an associative array. The key, which in this case is database, is the binding name, while the value, in this case is port, is a space delimited list of the exported configuration that the binding requires. You can specify multiple binds, which each would be an individual entry in this associative array. When defining your plan, So when defining your plan, you can override the default behavior of Habitat in each build phase through a callback, and that's called build phase callbacks. That's our last little block. To define a callback, I'm having trouble with English. You simply create a shell function of the same name in your plan file and then write your script. Simple. So in this example, we've got do prepare and do build. So do prepare, there's no real default implementation of this callback. At this point in the build process, the tarball source has already been downloaded, unpacked, and the build environment variables have already been set. So you can use this callback to perform any actions before the package starts building, such as exporting variables and so on. So for do build, you should override this behavior if you have additional configuration changes to make or other software to build and install as a part of building your package. This step builds the software, assumes the GNU pattern, and delegates most of the implementation to the do default build function. Okay, so let's go over some high-level Habitat architecture. We'll start with this Habitat Studio, which is a development kit for creating automated build and deployment plans for any application and testing them in a clean room environment. Habitat Builder acts as the core of Chef's application delivery enterprise hub. Plan files are stored in the Habitat Builder SaaS, where they can be viewed and accessed by the Habitat community and shared on on-premise versions of the builder, where they can then be copied and maintained locally. Some of the builder includes the following: the application manifest, deployment channel management, origin management, content libraries, custom data and reporting APIs, and DevOps integration APIs. And also, it has a nifty role-based user access. The supervisor is a process manager that has two primary responsibilities. First, it starts and monitors child services deployed as defined in the plan that it's running. Second, it receives and acts upon information from other supervisors to which it is connected. So you may have like a supervisor ring, and one of the jobs of the supervisor is to get instructions from other supervisors within the ring. A service will be reconfigured through the application lifecycle hooks if the configuration has changed. So it's kind of almost real time. It's pretty cool. Finally, we've got Chef Automate. And Chef Automate provides enterprise management and observability capabilities, and it's included in every Chef subscription. Automate offers visual UIs, real-time interactive dashboards, role-based access controls, third-party integrations, APIs, and much more. So let's dig a bit deeper into how Habitat works. So first, you define your application. To do this, you're going to use the Habitat, the clean room environment in Habitat Studio. This ensures that whatever is built and tested in this development environment will be the same when it's delivered to pre-prod, staging, and prod. In addition, the application definitions are created independently of any infrastructure so that they can be deployed in multiple runtimes without refactoring. After they defined the application and it's checked into version control, where it's ready to be packaged up by your CI/CD system, we call that piece, we call that the Habitat architect file, which is the heart file. That creates a signed and compressed and versioned artifact. It's pretty much everything you need to be confident in that the artifact that you built is ready to deploy. Once you have that artifact, you then feed it to the Habitat supervisor. Supervisor is our agent out in the field that sits out in your production environment and is waiting to take the package, unpack it, and run all the instructions that you defined in your plan. And it's also going to make sure that your application is deployed correctly and healthily. Then you're able to use the application dashboard to validate your application has been deployed correctly. Oh, what have we done? We've increased productivity. We gave dev test teams a place to efficiently build and test applications. Well, by enabling those teams to work more efficiently, we've helped eliminate defects. And by defining everything in an application, everything an application needs to be built, deployed, and run as a codified automated workbook, or runbook, we've enabled your release teams to deliver faster. We've also helped to eliminate manual processes, inconsistent execution of manual runbooks, runtime failures caused by missing configuration files and dependencies, and the amount of time that it takes to update and maintain applications, and exponentially the amount of effort that it takes to do the same. We've also helped hundreds of very mature companies accelerate holistically across their environments, pushing not just modern applications to the cloud fast, but these same old companies are able to leverage Habitat to automate and continuously deliver old, archaic, antiquated Windows COTS applications that were previously stuck on platforms such as Windows 2003. And we were able to modernize those without a rewrite. Think about that. It's pretty epic. And we're ready to help. That's been my talk. Let's open it up for questions.
Oh, that was brilliant. Thank you. It's bringing back memories of trying to figure out how it all works. It's really nice. One question that I've always had, and I've been asked so many times in the past, is how does Habitat differ from Docker? Because they're kind of similar containerized environments. They sort of package up all the tools together. They're sort of similar, but I think
yeah, absolutely. You know what? I actually had this question as well when I started working with Habitat, because it does seem very similar, right?
Yeah.
Especially by description, but they don't really overlap much. The main point of competition between Docker and Habitat is building release artifacts. Docker has Docker files and Docker build, and Habitat has plans in the studio. The output of both, though, can be a Docker image.
Right.
Right. So that basically is just a tarball of a file system along with some metadata. Habitat is aimed more at building super minimal artifacts, which is like not including the Linux distro or any package managers or anything, just statically compile executable code and whatever support files you need for that specific app.
That's cool.
Yeah.
Yeah. That's I think it's a nice sort of overview of Habitat. I like the fact that the supervisor's just sort of sitting there waiting for you to like it can sort of gobble your packages up and be like, right, I'm waiting for the next command, which is pretty nice.
Exactly. And then like the fact that it will update, even like a production app, like that's something that I would be afraid to do. But it works. I mean, people, like, there are companies that are using it, and it's working for them. And I think that's amazing. Like, hearing about Habitat and how it works, especially in production environments, is almost surreal, because you think about all of the toil that goes into deploying applications, and it really automates a lot of that, and it removes the human error perspective out of a lot of that. So
that's really cool. Yeah, there's the dependency chain is really interesting as well. That's the whole transitive dependencies, which is also a really hard word to say, and apparently you just breezed by it. Is sort of really interesting. So the build tool chain for Habitat's quite bespoke almost, isn't it? Because they're really like, once you dig into that part of the build chain and how it works, I think that's where it completely sold it for me. I was like, oh yeah. And the fact that it's all static now is just really nice.
Yeah.
Cool. If we don't have any more questions, which I don't see any at the moment, I think we'll call it there. Thank you very much.
Awesome. Thank you. Thank you, everybody. Enjoy the rest of the talks for Chef Conf. Thank you for coming to mine. And I hope to see you on the community Slack.